So we have talked about some of the basics of BDD and TDD. Software testing is a whole thing. Like there are books about it. There's, entire courses where all you talk about is testing. But again, in 14 weeks, all we can really do is make sure that you know what the landscape looks like so that you know what you don't know. So to that end, here are some other terms related to testing that you may hear. Mutation testing is a pretty cool one. Essentially, it says, if I insert bugs deliberately into the source code, does some test break? And if the answer is no, then you probably have gaps in your, even if your coverage looks good, you may be failing to test some important behaviors if introducing a bug into your source code does not cause any test to fail. And in fact, when you start working on CHIPS 8.5, in which what you are doing is essentially writing RSpec test cases, this is actually how the autograder works. The autograder works by inserting bugs into the code for which you are writing tests and making sure that when that happens, some test that you wrote fails. That means that's a good test. Somewhat related to that is fuzz testing, which is basically throwing random input at your code. So for a web app, this means loading a random page, even if the page is loaded out of sequence, clicking in random places, filling in random garbage on all the form elements. Your app, may or may not react to these things in a sensible way, but it shouldn't crash. And in the past, fuzz testing has been able to successfully crash about 25% of all of the Unix utilities. So basically think about fuzz testing, when you're writing your scenarios and your RSpecs and stuff, you're kind of thinking, when people are using the app the way it's meant to be used, does it behave correctly? Fuzz testing is about testing the app the way that it wasn't meant to be used. There's also another term that you may hear it called DU coverage, for define and use. So basically, look at every place in the code where some variable is set, in other words, the definition, and a later place where that variable's value is consumed by another expression. That is a DU pair. And if a particular variable is defined once and used 5 times, that is 5 DU pairs. So DU coverage is what fraction of every DU pair is actually exercised by the test suite. As you can imagine, also very hard to get. But, given all that we've said about how much is it worth going out of your way to get every path covered or every define and use pair, if your software is going to be, for example, in space, this kind of thing actually matters, right? If you cannot easily rev your software, if having your software crash would be bad, because it might lead to an actual real physical crash of something like a spacecraft, there's a scenario in which these sort of much more detailed test cases actually are worth doing. You may also hear the expression black box test versus white box, sometimes glass box. Basically, the question is, does your test know about the internals of the method being tested or not, or how much does it know? So the classic example of this is something like, you've got a method that figures out whether it's a leap year or not, right? If you know the rules for leap years, you will probably try to have tests where you pick boundary values to make sure that at the boundaries, those critical values, your method does the right thing. That makes it a glass box or a white box test because the test specifically knows something about the implementation and is testing that thing. A black box test for that would be like, I'm just going to give a bunch of random years to it and just check if the result is correct for each one. But there's no attempt to sort of trick the function into doing a wrong thing. The equivalent thing for a hash table, right? If you're testing a hash function, a black box test would just be, if I put things in the hash table and then I retrieve them, do they come out right? A glass box or a white box test would be something like, I'm going to try to trick it to make its loading factor be pessimal. What happens if I do that? Can I trigger a pathological behavior? So if I had to summarize, what have we learned? Red-green refactor is probably the biggest thing, right? And there's like this double loop where you're doing this on the outside by trying to get your Cucumber steps to pass. And in so doing, for each one of those steps, you're adding code to your app and you're developing that code using TDD. Because you can test one behavior at a time, that's what TDD gets you. Use seams everywhere. Really isolate the code from everything else except the one behavior you're trying to test, and incrementally backfill the code so that you're testing more and more behaviors until you've gotten to the point where your scenario step is now passing. You can use placeholders. So remember, every RSpec example begins with it, and there's a sort of a doc string that tells you what the test is going to do. Normally, that's followed by a do end block, but it's legal to just say it and have a doc string and have a bunch of those. So basically, you can start thinking about the tests you need to write. You can insert the doc strings for them and then start filling in the tests as you go. Coverage is your friend. Look at the coverage reports. If you run the SimpleCov tool that comes with Ruby, it generates these really nice formatted pages where you can like look at each source file and you can see by color of each line which lines got exercised by which tests. So again, it's not where you're aiming for a very specific threshold number, but use test coverage information to identify places that clearly need better coverage. And related to that, don't rely too heavily on any one kind of test. Every kind of test has its uses, and each one will find types of bugs that the others will miss. So having a robust and healthy comprehensive test suite is your friend.